Lipids are heterogeneous heterogeneous organic compounds insoluble in water and soluble in organic solvents. Insoluble in water and soluble in organic solvent. Organic solvent like ether, organic solvent like acetone, like benzene, okay, chloroform, okay? And this is classified into simple lipids. Simple lipids, for example, triacylglycerol and wax. Triacylglycerol and wax. So this is simple lipids. It's triacylglycerol, acyl, acyl. Okay, triacylglycerol or wax. The difference between wax and the triacylglycerol is the wax a very long chain alcohol, consisting from fatty acid and very long chain alcohol. So acyl. Okay. Complex lipids like phospholipids. So complex lipids like phospholipids. Okay, phospholipids, for example, glycophospholipid. For example, lecithin, diphosphatidylcholine, phosphatidylcholine, dipalmitoid phosphatidylcholine. So maybe choline, it is lecithin. Ethanol amine, it is cephalin. Phosphatidylanisitol, phosphatidylglycerol, and so on. Okay? Phosphatidylserine. Second class of the phospholipids is the sphingolipid. So this is the glycophospholipid. Second, it's sphingolipid. For example, sphingomyelin. Sphingomyelin is the sphingolipid. There is also glycolipid. So glycosylated lipids. So it's complex between carbohydrate and lipid. Lipoproteins is also complex between lipid and proteins. Lipoproteins. So it is lipid and protein. For example, low density lipoprotein, high density lipoprotein, very low density lipoprotein, intermediate density lipoprotein, and chylomicron. Okay. There is also sulfatides. Sulfatides, it is glycolipid. Okay, sulfated glycolipid. And there is also glycolipid, like cerebrocyte, glucocerebrocyte, galactocerebrocyte, lactosyl cerebrocyte. Okay, yes. There is also derived lipids, so simple lipid, complex lipid, derived lipid. What is derived lipid? Derived
Fatty
lipids or
acid.
precursor lipids are lipids which derived from other lipids, so our biological system can prepare it, or can be synthesized by hydrolysis. For example, hydrolysis of triacylglycerol, it is fatty acid and is glycerol. So fatty acid is derived from triacylglycerol. Okay. Also cholesterol. Cholesterol is derived lipid. Cholesterol. Ketone bodies are derived lipids. Okay. So they are derived from acetyl-CoA. Derived from acetyl-CoA. And acetyl-CoA from beta oxidation of fatty acid. So they are derived from other lipids. Digestion of lipids. What are the functions of lipids? Function of lipids is number one is the second source of energy after carbohydrate. Second source of energy after carbohydrate. Number two, structural function. Structural function. Cell membrane, for example. And many receptors are glycoprotein. Receptors on cell membrane. It's a glycoprotein. And the lipoprotein. Lipoglycolipid. For example, antigen of red blood cells. Antigen of red blood cells. So antigen of red blood cells, it's a glycolipid. So they are receptors. Okay. Receptors for antibody. Antigen, antibody interaction. Okay. Surfactant. Lecithin is a surfactant. Phosphatidylacetyl, it is secondary messenger. It is secondary messenger. It is source of anisitol triphosphate. Anisitol triphosphate is the compound which can bind with the endoplasmic reticulum and releasing calcium from endoplasmic reticulum. Elevation of calcium cytoplasm led to muscle contraction. Okay, so phosphorylation of myosin. Phosphorylated myosin or phosphorylation of myosin caused by elevation of calcium. Okay, elevation of calcium will lead to binding of calcium with modeling, calmodulin. When calmodulin activated by binding of calcium, the calmodulin kinase will be activated, and calmodulin kinase will phosphorylate the light chain myosin. When myosin phosphorylated will interact or cross-linked with the actin and production. Okay? There are important compounds produced from lipids, for example, bile acids. Bile acids produced from cholesterol, cholic acid, glycocholic acid, chenodeoxycholic acid, glycocenodeoxycholic acid, taurochenodeoxycholic acid, taurocholic acid, litocholic acid, and deoxycholic acid. All of them are produced from the cholesterol. 6 hormones, male or female, 6 hormones, progesterone, testosterone, estrogen, produced from cholesterol. Hydrocortisone, aldosterone, produced also from the cholesterol. So lipids are very important compounds. Okay, digestion of lipids. Digestion of lipids started at mouth. Okay, started at mouth. Digestion of lipids started at mouth. Okay. Digestion of lipids started at mouth. There is sublingual lipase. Sublingual lipase. Okay. Sublingual lipase, it is in saliva, yes? Okay. Can work at acidic medium. So synthesis of sublingual lipase in mouth by gene expression, and only can hydrolyze the light chain or short chain fatty acids. So this is the triacylglycerol. Okay. So only if the acyl consisting from short chain, so from 4 to 6. Okay, 7 can be hydrolyzed. So sublingual lipase hydrolyzing the acyl, but which acyl? If the acyl consisting from short chain carbons. So fatty acids classified into short chain, medium chain, long chain, very long chain. So if the fatty or acyl consisting from medium chain fatty acid cannot be hydrolyzed by sublingual lipase. So synthesis of sublingual lipase in mouth, but can work even in stomach. Okay, can work in the stomach. Okay, so only can hydrolyze the short chain acyl to fatty acids. Okay, in the stomach there is a gastric lipase. So sublingual lipase in mouth, gastric lipase. And gastric lipase can hydrolyze the short chain and medium chain. The synthesis of the gastric lipase in the stomach, but cannot work on the stomach, only can work in the intestine. So mouth can work in the stomach, but gastric lipase cannot work on the stomach, will work in the intestine. So will work at the neutral to basic pH. But the main important role plays the pancreatic lipase. Pancreatic lipase. And pancreatic lipase can hydrolyze all classes of fatty acids: short, medium, long, and very long. Okay. And pancreatic lipase can only work in aqueous medium. So, the pancreatic lipase cannot work with our bile acids. The function of bile acids is emulsification. Okay? So, this is the granulous lipid. Granulous lipid. Okay. The bile to intestine, this is bile. The bile acids. What is the bile acids? Cholic acid. Okay. Glycolic acid, and the glyco is abbreviation of glycine. So cholic acid conjugated with glycine, it's a glycolic acid. اتينو ديوكسي كوليك أسيد جلايكو سينو ديوكسي كوليك أسيد اوكي تاورين it is amino acid تاورين تاورو كوليك أسيد تاورو اتشينو ديوكسي كوليك أسيد
لكن مش كلهم برايمري.
all of them are primary. These are primary bile acids. So these compounds are primary bile acids. Primary bile acids. Okay, when bind with the sodium, they are become salts, bile salts. So in basic medium, bicarbonate, and the an intestine will convert it to bile salts. And intestine by bacterial flora, the primary bile acids will convert it to secondary. So there is bacterial flora in the intestine. Number one, bacterial flora will dissociate the amino acids from bile acids. So taurine will release it, glycine release it. Okay, and cholic acid will catabolize it to deoxycholic acid by bacterial flora, and deoxycholic acid to lead to cholic acid. Therefore, we call it secondary. Why? Because secondary modified by bacteria. So primary prepared by our biological system. Secondary, it is just effect of bacteria on the primary. So secondary prepared by bacteria from primary. Okay? But there are amphoteric compounds consisting from polar and non-polar. Okay? Okay, so consisting from polar and non-polar. Okay. So these bile acids will be coated. This is hydrophobic. So bile acids will degranulate, dividing big granule to small granule. So this is fat, cholesterol ester, okay, and the bile acids will coat the lipid globule. Corradi lipid. Okay. Hydrophobic, or pancreatic lipase cannot work without coating. So the polar groups will be outside. And the hydrophobic part of the bile acids, bile salts, will bind with. So this part is hydrophobic bond. Okay. So this is lipid, this part is lipid, the hydrophilic part will be outside. And water will coat the lipid. So the lipid bile acid will be divided to small molecules and become emulsion. Emulsion. So what is the emulsion? It is lipid in water. So lipid coated by water. So without bile acids, the lipid cannot be dissolved in water. Okay, if lipid cannot be dissolved in water, pancreatic lipase cannot work. Why? Because pancreatic lipase is water-soluble compound, cannot interact with lipid. Okay, can only dissolve in water. So when dissolved in water, okay, so pancreatic lipase around the lipid, then can hydrolyze lipid to the fatty acid and glycerol or monoacyl glycerol. Okay? So this is the triacyl glycerol or acyl or acyl or acyl. Acyl may be short, long, very long, whatever. The pancreatic lipase can only work at carbon number 1 and carbon number 3. Cannot work at carbon number 2. Okay, cannot hydrolyze the acyl at carbon number 2. Can only hydrolyze the acyl at carbon number 1 and acyl at carbon number 3. Okay, this is glycerol, CH2, CH2O. So 1, 2, 3, or alpha, beta, gamma. Alpha and gamma, or 1, 3 only. Okay, or SB, SN1 and SN3.
شو تسوي بعد الدواء؟
There is no active site. Okay, but there is enzyme which can change or displace the acyl at carbon number 1, carbon number 2 to carbon number 3. Isomerase enzyme. So, isomerase enzyme will change the position of acyl from carbon number 2 to carbon number 3. Then the pancreatic lipase can hydrolyze. Okay, so only can hydrolyze the acyl at carbon number 1 and carbon number 3. Okay, so there are 3 main enzymes involved in the digestion of lipid. Lingual lipase, short, gastric lipase, medium, and pancreatic lipase, the major and the big role in the digestion of lipid plays the pancreatic lipase. So pancreatic lipase is the most important enzyme in digestion of lipid. Importance of gastric and lingual lipase. The gastric and lingual lipase very important for neonates. Why? Because neonates are dependent in milk, and milk consisting from short and medium chain fatty acid. Okay, so very important. Also, short and medium chain lipases important in case of pancreatitis. So in pancreatitis, okay, or in cystic fibrosis disease of pancreas, yes, low amount of pancreatic lipase secreted from pancreas. So, cystic fibrosis, physicians and doctors will recommend the patient to be so far from lipid. Okay, so if he must get a lipid, he must get shorter chain or longer chain. So far from short
Medium.
and medium chain. So far from longer chain. Therefore, the lingual and the gastric lipase very important in pancreatitis. So, okay. So what is the function of bile acids? Emulsification, converting the lipid to emulsion. What is the emulsion? Lipid in water. Okay? Without emulsification, no digestion. Okay. But inability to digest the lipid. What is the inability to digest lipid? It is tetaria. So what is this tetaria? It is inability to digest lipid. What are the causes of diarrhea of tetaria? Tetaria, maybe
Obstruction.
bile stool, obstruction of bile duct or obstruction of hepatic bile duct. Okay, or liver disease. Why? Because synthesis of bile acid is where?
كل الليفر.
In liver. Okay.
Some drugs have to do with
Okay. And synthesis of bile acids from the cholesterol. This is the cholesterol. Okay. A, B, C, D. This is the sterol ring. This is the structure of cholesterol. The regulatory enzyme for the synthesis of bile acids, it is 7-alpha hydroxylase. 7-alpha hydroxylase enzyme. Okay. Cholic acid, chenodeoxycholic acid, and very, 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 very long or very lots of steps. Lots of steps. Okay, NAD, BH to NAD B, and NAD BH from the hexose monophosphate pathway. Okay, so the regulatory enzyme, this is the regulatory enzyme inhibited by feedback inhibition. Okay, so what is this tetaria? Tetaria, it is the presence of undigested lipid in the stool. Why? Okay, the synthesis of the bile acids in liver. So liver cancer is the causes of tetaria. Why? Because the place of synthesis of bile acids in the liver. So if liver damaged, no bile acid is produced. Okay, and also uronic acid pathway cannot be okay. So no glucuronic acid, no glucuronic acid, no bilirubin can be conjugated. So it is jaundice. But which class of jaundice? It is hepatic jaundice. Hepatic jaundice. Okay. A second cause, when the pancreas damaged by pancreatic cancer. No, so no lipase, pancreatic lipase produced from the pancreas. Number 3, head of pancreatic cancer. Head of pancreatic cancer. Head of pancreatic cancer, when the head of pancreatic cancer elevated due to cancer, will close the hepatic, bile duct obstruction. Number 4, inflammation of the intestine. Inflammation of the intestine. Autoimmune disease. When our biological system, our immune system, attacking the epithelial cells in intestine, damaging the epithelial cells of intestine, the intestine unable to absorb the lipid. So sometimes our immune system recognize the epithelial cells or our native cells as foreign body, as antigen. So for antigen, the immune system will produce the antibody attacking the native cells, unable to absorb. Okay. Early state, it is the medication used for weight loss. Okay? So the early state is the drug bind covalently with pancreatic lipase, inhibiting the hydrolytic or catalytic activity of the pancreatic lipase. So what is this area? It is the presence of bile and digested food in stool. Causes? Liver diseases?
pancreatitis.
Pancreatitis?
Cancer في هذه.
Cancer of the pancreatic cancer? Bile stone?
لا ماشي في الانتستين.
Medication?
Inflammation.
Intestinal inflammation or autoimmune disease in the intestine. Okay? Or parasitis, Giardia lamblia, parasitis. Okay, so any disease in intestine will decrease the ability of intestine to absorb the food. Okay. So, but there are other enzymes involved also in digestion. It is intestinal lipase. It is intestinal lipase. And intestinal lipase can hydrolyze all the fatty acids at all 3 carbons. So alpha, beta, or gamma, 1, 2, 3. Okay, there is also cholesterol esterase. This is the cholesterol. Cholesterol esterase, this aside.